This is a really short video because I couldn't find one online that did what I wanted to do. So this combines, rather, this will find, we want to find the derivative of y equals e to the x. This is a really nice function that shows up a lot, and we want to find the derivative using what we just learned about implicit differentiation. So here's how this works. We want to take the derivative of y equals e to the x, but we don't know how to do that. So let's take the natural log of both sides. Then we get ln of y equals x. Well, we learned recently how to take the natural log of x, so to take the natural log of y, we can do the same thing. So now we're going to take the derivative of both sides with respect to x. So remember, we're going to take d dx of ln y and take d dx of x. Remember, d dx is an operator. It says take the change of whatever follows with respect to x. So take the change of ln y with respect to x, take the change of x with respect to x. All right, so using implicit differentiation, we get that the derivative of ln of something is 1 over that something times dy dx. I imagine people are going to have a little bit of question on here, but remember, like, this is like ln of a function. It's a chain rule problem. Think about this. Come in with questions if it doesn't make sense. Okay, so we have 1 over y times dy dx equals dx dx. Well, dx dx is just 1. So that's going to go away. Then we want to isolate dy dx because that's what we're looking for. So we're going to multiply both sides, this side by y and this side by y. And so we get dy dx equals y. And that's really cool. That's saying that the amount that y changes with respect to x depends on how much y there is. We oftentimes use e to the x to model like populations growing or money growing. So the amount that a population grows or the amount that money grows depends on how much money there is or how much population there is. So that makes sense that the rate of change depends on how much there is. We'll get back to this later, but this is actually really important. This is called a first order differential equation, but you don't need to know that for right now. But if you want to, this is one of the kind of easiest types of diffie-Qs, diffie-Q being a major field of calculus that you'll study at some point, or you may. Anyway, so since we know dy dx equals y, and we know that y equals e to the x, we know that dy dx equals e to the x. Cool.